Hello everyone, this is Miss Risk. We're going to go over scientific notation practice problems today. Let's start with definition.
Scientific notation expresses any number as a number between 1 and 10, known as a coefficient, multiplied by 10 raised to a power, known as an exponent.
Okay, so we have two numbers we're dealing with. We have the coefficient and we have the exponents. The number of places moved equals the value of the exponents. So when we move the exponent to the left, when we move the decimal to the left, your exponent is positive, and your exponent is negative when you move the decimal to the right. So for example, 800, you move the decimal 2 places to the left until there's one number to the left. So it's 8.0 times 10 to the second power. For this one, we move 1, 2, 3, 4, 5 places to the right, so it's going to be a negative 5. 3.4 times 10 to the negative 5. We have practice problems 12 and 13. So 700, the decimal is right here. We move 1, 2 places. So it's 7 times 10 to the positive 2 because we move to the left until there's one number to the left. 38,000, we move 1, 2, 1, 2, 3, 4. So 3.8 times 10 to the positive 4. And then we have 1, 2, 3, 4, 5, 6. 4.5 times 10 to the positive 6 because we move to the left until there's one number to the left. And then this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 6.85 times 10 to the 11th power. And then this 0.0054, we move the decimal 1, 2, 3 to the right. So it's going to be a negative 3. 5.4 times 10 to the negative 3. And then F, we move to the right 1, 2, 3, 4, 5, 6. 6.87 times 10 to the negative 6 because we move to the right. And then G and H we did for homework. Of course, you can pause and copy if you have to. I'm just going over it. Number 13, still the same. So 360,000, decimal to the left. 1, 2, 3, 4, 5. 3.6 times 10 to the positive 5 because we move to the left. And then 0.000054, we're moving to the right, so it's going to be a negative number. 1, 2, 3, 4, 5, negative 5. 5.4 times 10 to the negative 5. And then C and D were for homework. And then we had number 14, where we are adding scientific notations. And if their exponents must be the same in order to just add and subtract coefficient. This one is negative 5, negative 5. So all you have to do is add coefficients. So 5 plus 2 is 7. 7 times 10 to the negative 5. You bring down the negative 5. This one is positive 8, positive 8 exponents. All you have to do is subtract the coefficient. 7 minus 4 is 3 times 10 to the 8th power. And then C and D, 2 and positive 2 and positive 2, subtract the coefficients. 9 minus 7 is 2, 2 times 10 to the second power. For D, negative 12 and negative 12, so all you have to do is add the coefficient. So it's 5 times 10 to the negative 12. Now this one is if not equal, if the exponents are not equal, one is 4, one is 3, you take the smaller number, move the exponent to the left until they're equal. So this is the smaller number. Move the exponent to the left one place, so both of them will be times 10 to the 4th power. Now all you have to do is add the coefficient. 1.6 plus 0.25 is 1.85 to the power times 10 to the 4th power. And then for F, it's -3, -4. This is a smaller one, so you move to the left one place. Both of them will be -3, the exponents. And then now all you have to do is add the coefficient. So we have 7.18 times 10 to the -3. I think we have one more. Yep. Exponents 5 and 4. So we take the smaller one, move it to the left one place. So both of them will be 10 to the 5th. And then all we have to do is subtract the exponents. 4.39 minus 0.28 is 4.11 times 10 to the 5th. And in this one, -1, -2, we take the smaller one, move it to the left, the decimal to the left. So both of them will be 10 to the -1, and then subtract the coefficient. And we get 4.62 times 10 to the -1. Now multiplication and division. When you multiply the coefficient, add the exponent. So 4 times 1 is 4. 8 plus 2 is 10. So 4 times 10 to the 10. This one is 2 times 3 is 6. -4 plus 2 is -2. So 6 times 10 to the -2. C, 3 times 3 is 9. And then you add 1 plus -2 is -1. 9 times 10 to the -1. And then for D, 5 times 1 is 5. And then 3 positive -1 is 2. 5 times 10 to the 2nd power. 16, we're dividing. When you're dividing, you divide the coefficient, subtract the exponent. So 6 divided by 2 is 3. And then 2 minus 1 is 1. 3 times 10 to the 1st power. 8 divided by 4 is 2. And then 4 minus 1 is 3. So 2 times 10 to the 3rd power. Okay, for C, we're still dividing. So 9 divided by 3 is 3. And then 5 minus 1 is the same as 5 plus 1 is 6. So 3 times 10 to the 6th power. For D, 4 divided by 2 is 2. And then -3 minus -2 is the same as -3 plus 2 is -1. 2 times 10 to the -1. And then the same section we did the converting between units.
Dimensional analysis. A systematic approach to problem solving that uses conversion factors to move from one unit to another. Conversion factor. A ratio of equivalent values used to express the same quantity in different units, is always equal to 1 and changes the units of a quantity without changing its value.
All right, so when we are dealing with conversion factor, we're converting between eggs to dozens of eggs, or meters to centimeters, or seconds to milliseconds. We're using conversion factor to cancel one unit and introduce new ones. Okay, so in this case, we cancel out person, bottles, and then we end up with 8 packs. Convert 360 seconds to milliseconds. There's 1000 milliseconds per second. We always start with what's given, and then we use the conversion factor, so we cancel out the units that we don't want, which is seconds, and we introduce new one, which is milliseconds. And then we end up with 360 times 1000, 360,000 milliseconds. We can convert that to conversion factor. To scientific notation. You move the decimal 1, 2, 3, 4, 5 places to the left, so it's +5. 3.6 times 10 to the +5. Convert 4,800 grams to kilograms. There is 1,000 grams per kilogram. We start with what's given, 4,800, divide by 1,000. So grams will cancel out and we end up with kilograms. Divide 4,800 by 1,000, you get 4.8 kilograms. C and D were for homework. 18, convert 245 milliseconds to seconds. There's 1,000 milliseconds per second. And we start with what's given, 245. To cancel out millisecond, you divide by 1,000. Milliseconds cancel out. So 245 divided by 1,000 is 0.245. For B, convert 5 meters to centimeters. There is 100 centimeters per meter. We start out with meters, multiply by 100 centimeters. Meters cancel out, 500 centimeters. And C and D were for homework. Now number 19, how many seconds are per 24 hours? We start with hours. Here's 60 minutes per hour, 60 seconds per minute. Multiply 60 times 60 times 24 is 86,400 seconds. Now 20, the density of gold is 19.3 grams per milliliters. What is the gold's density in decigrams per liter? Convert grams to decigrams. So there's 10 decigrams per gram. And in milliliters, there's 1,000 milliliters per liter. So we multiply 19.3 times 1,000 times 10, we get 193,000. Okay, and 21 was for homework. So that concludes scientific notation and dimensional analysis. We'll see you next time.